Welcome to today's lecture on the define phase of the Lean Six Sigma methodology. This stage is perhaps the most critical because if we don't define the problem correctly, no amount of measurement, analysis, or improvement will be able to fix a process effectively. In this session, we will take a detailed look at the 5 most widely used tools to define and scope a process improvement initiative. The IPO diagram, the SIPOC diagram, the flow diagram, the CTQ tree, and finally, the project charter. By the end of this session, you will be able to explain what each tool does, when to use it, and how to construct one for your own projects. You will also design a beginning project charter. Let's start with the IPO diagram, short for Input Process Output. This diagram is one of the simplest yet most insightful tools in the define phase. It helps clarify what inputs are needed to carry out a process, what transformation or steps are involved, and what outputs are produced. Think of it like a black box model. What goes in, what happens inside, and what comes out. In Lean Six Sigma, we often refer to inputs as X variables and outputs as Y variables. The process acts as the transformation engine between these. For example, in a pharmaceutical company producing tablets, inputs might include raw materials like active ingredients, excipients, and packaging. The process includes mixing, pressing, and coating. The output is the finished tablet, measured for uniformity, weight, and compliance with regulatory standards. The steps to create an IPO diagram are: choose a process you want to analyze. Identify the key outputs. These are typically customer-driven quality requirements, or CTQs. Determine the required inputs to meet those CTQs. Sketch out the relationships using a simple arrowed layout. To sum up, the IPO diagram is often one of the first you'll use in a Six Sigma project. It helps teams think clearly about process boundaries, expectations, and what matters to the customer. Next, we move to the SIPOC diagram, which gives us a high-level view of a process, not just as a set of activities, but as a chain of interrelated stakeholders and deliverables. SIPOC stands for Supplier, who provides the inputs? Input, what resources are used? Process, what steps are performed? Output, what is produced? Customer, who receives the outcome? The SIPOC diagram is especially valuable because it gets teams thinking about the broader supply chain and customer expectations. It's ideal early in a project before diving into the details. Let's walk through an example. A company leases medical equipment to hospitals. Suppliers provide machines and service manuals. The inputs include the actual devices, documentation, and trained personnel. The internal process involves equipment testing, contract setup, and delivery. The outputs are the installed functional machines. And the customer is the hospital's procurement department. These steps to build a SIPOC diagram are: define the process and its boundaries. Identify what inputs are needed to run that process. Determine who supplies those inputs. Specify the outputs of the process. Identify all customers who rely on those outputs. To sum up, the SIPOC diagram helps align the improvement project with stakeholders and define expectations. It's also a helpful precursor to writing a project charter. Now let's look at the flow diagram, sometimes called a process flow chart. This tool helps us visualize the sequence of activities that make up a process from start to finish. Each activity, decision point, and outcome is charted using standard symbols. Ovals represent start and end points. Rectangles show tasks or activities. Diamonds indicate decision points. Circles serve as connectors across pages or sub-processes. For example, let's say we're examining a university's purchasing process. The process begins with a purchase request, which is reviewed for budget availability. If approved, a purchase order is issued. If not, the request is sent back for revision. This entire workflow can be captured in a flow diagram to uncover inefficiencies. Now, in terms of steps to build a flow diagram, you must first clearly define the start and end points. Next, brainstorm and list all major activities and decisions. Then, place them in logical sequence. And finally, use flowchart symbols to build the diagram. This tool is practical for identifying where problems occur, where delays build up, and how handoffs happen between departments. In building flow diagrams, you can start with sticky notes or a whiteboard to map your steps collaboratively before drawing the final version. Flow diagrams are powerful for building team alignment and process understanding early in a project. Next, we have the CTQ tree, one of the most important tools for translating broad customer needs into specific measurable requirements. CTQ stands for critical to quality. A CTQ is an attribute of a product or service that must be met to satisfy the customer. The tree format helps break down general wants into granular expectations. For example, suppose you're managing room service at a hotel. A guest might say they want fast service. But what does that actually mean? By using a CTQ tree, we can clarify that fast means food must be delivered in under 30 minutes hot and with the correct order items. Steps to build a CTQ tree are identify the customer or customer group, capture their general needs or wants, break those into measurable first-level requirements, drill down to the specific behavioral or technical CTQs, validate your findings with the customer. To sum up, CTQ trees bridge the gap between abstract desires and practical design or service criteria. Finally, the most formal tool in the define phase, the project charter. The project charter sets the foundation for the entire Six Sigma project. It defines the problem, the goals, the team, the timeline, and expected business outcomes. It's a contract between the team and stakeholders. Key components include a descriptive title, a concise problem statement, the purpose or rationale for the project, clearly defined scope, what is and isn't included, measurable objectives, the team structure and roles, identified customers and CTQs, an initial cost-benefit estimate, and a project timeline. For example, DuPont Teijin Films created a charter to improve safety performance at a manufacturing plant. The document laid out the problem, including high incident rates, the project's scope, specifically all on-site staff, and the target objective, being 50% reduction in recordable incidents over 6 months. There are several steps to build a project charter, including choose a project with real business value and Six Sigma fit, identify stakeholders and CTQs via SIPOC, make rough estimates of costs and benefits, secure leadership buy-in, assemble a capable team, draft and validate the charter, update the document as the project evolves. For some final advice, always use the charter, not just as a planning document, but as a tool to keep alignment throughout the DMAIC phases. As Einstein once said, if I had 1 hour to save the world, I would spend 59 minutes defining the problem and 1 minute solving it. That perfectly sums up why these tools are so essential. Each tool we've discussed, IPO, SIPOC, flow diagrams, CTQ trees, and the project charter, brings structure and clarity to project definition. None of them require specialized software or deep expertise, but each adds tremendous value by focusing your team's attention on the right things at the right time. Before rushing into measurement and analysis, pause and make sure your problem is clearly defined and understood. Thank you for watching. Now, let's get to applying some of these tools to your own project.